So in this video, let's talk about the electron transfer in photochemistry. When we are talking about the electron transfer, there are two types of it, right? First thing is it can be done in ground state. Or the electron transfer can be happen in excited state. Now, if we are looking at the ground state, right, the basic reaction would be like this. Let's say we have two compounds. The one would be acceptor, another one would be the donor. So we have talked about this acceptor and donor thing in our previous video. If you have missed it or if you want to watch it, I will put the link here. You can watch it if you want. Now, the acceptor is basically the one who gains energy, or in this case we are talking about the electrons now. So acceptor, this is the acceptor. This is the compound which obtain electron from the donor. This is the donor. Donor is the compound which give away its electron. Since we are talking about the electron transfer here, we will say that donor is the one who is giving away its electron to the acceptor. Now, when these two are collide each other, right, what happens is one electron will be missing in our donor. So I can put our donor like in a positive charge because it has lost an electron, and when I put the acceptor, it has gained an electron. So here we have an electron over here in acceptor. So basically I will put one electron here. Okay, just like this. Now this is the basic reaction for electron transfer in ground state, right? So no compounds has been excited into higher energy states. The whole process is performed under the ground state. Now I just want you to introduce this one equation which describes the Gibbs free energy for this process, right? So if I introduce this Gibbs free energy for this particular electron transfer, it has two components. The first one we denote as the donor, and here we have the acceptor term. So basically this term represents, right, this term represents the ionization potential of the donor. And this term here, right, this represents the electron affinity of the acceptor. So basically what this means is electron affinity means like our acceptor here, right, in what scale would it like to obtain electron. Like you get the idea, right? When we talk about the acceptor, which means it needs to obtain electron. So how possible is that particular process? Whether this particular compound likes to obtain electron or not, that's the component here which we are representing, right? In this case, we are talking regardless of our we are talking about the donor. Now donor has to remove its electron in order to give away. So what is the possibility of that particular process, whether our donor was almost like to lose an electron or whether it's not like to lose the electron. That particular process, the indicator is represented in here. So based on these two energy differences, we can obtain the delta G or the Gibbs free energy change. So this is for the ground state, right? This is for the ground state. Now let's look at the excited state. So when we have the excited state, energy transfer, right, the mechanism, first the basic reaction, I can represent it like this, right? So here we have the donor in the excited state, and we have the acceptor in the ground state. Now when the reaction happens, right, when the reaction happens, what happens is our donor will lose an electron and our acceptor will obtain an electron. So there can be two pathways for this. So here I'm going to represent our excited donor. So here we have the ground state, here we have the excited state. So now when it comes to the excited donor, we have one electron here. Okay, we have one electron here. Let's forget the spin, shall we? Right, the spin can be like that. Excitation can be in a triplet state or single state, right? We have talked about these singlet and triplet states in our previous videos. So in this case, for now, I'm going to forget about this singlet and triplet state. So here we have one electron, and here we have the other electron. So there should be two electrons. No? Electron pair is there. The one electron has been excited. Now when it comes to our acceptor over here, okay, when we have the acceptor over here, we have both electrons in the ground state, because here the acceptor is in the ground state and our donor here is been excited. That's why I have put the electron in the higher energy states. Now what happens here is our donor will give away its excited electron to our acceptor's excited state. So this is one possible way which this electron transfer can happen. In the other case, right, now what happens is, then we have here we have the donor, only one electron is there. Now you can see the excited state is not been populated because the populated electron has been transferred. In our A or the acceptor, we have an excited electron, right? We have excited electron. Now A has been obtained an electron from our donor. Now when we look at the other possible way, let me erase this. Okay, when we look at the other possible way, which is, let's say here we have the donor. Okay, the donor is not the one which have excited here. So donor has two electrons on the ground state, and in the case our acceptor is being excited. Now when the excitation happens, what is the representation? Here we have one electron, the other electron is being excited. This is the process. Now in this case, what happened? The donor will give away its electron from the ground state to the acceptor's ground state. Now we have the result. Here we have the donor, the positive charge, with one electron is there because other electron has been transferred. And here we have the acceptor. It has both electrons in the ground state and the excited electron is same as there. So this particular electron here, let me represent, okay, this particular electron here, it's the one from the donor. This is the process. This is the electron process. So if I write the mechanism for or the reaction for this particular process, here we have the donor and we have the excited acceptor. When the collision happen, right, we have the donor in the positive charge and we have the negative charged acceptor in the excited state. Now this is the process. These are the two processes available for electron transfer in excited state. Okay, so we have talked about two ways basically for the electron transfer. One is in the ground state. So it's basically a simplest way, right? Now here we have the acceptor, here we have the donor, and we have acceptor have gain electron and donor has removed electron. Now in the excited state, right, in excited state we have two mechanisms. Either acceptor can go to the excited state and donor can be in the ground state, or our donor can be in the excited state and our acceptor can be in the ground state. Now if we look at the energy terms here, right, here if I look at the energy terms, so let's take the excited state here, if I write an expression for delta G electron transfer, okay, so here we have a little bit different expression than the previous one, right? We have the energy term for the donor and we have the energy term for the acceptor, right? And we have another energy term, okay. So this is basically the previous one which we have talked about in IPD. So let me just write it as the previous one. So here, just like this one, this is the one expression that we have obtained for the delta G in the ground state. As you can see, there are two terms which representing the donor and acceptor. In this case also there are two terms. Here we are representing the delta G for electron transfer. Now we have the two terms, basically the same terms. This is for the donor and the other one is for the acceptor. Okay. Now other than these two, we have another extra term for the excited state, right? For the excited state. So this term represents the potential of excited energy term. Let me write it. Potential of excited state of the donor. Or the acceptor, right? So as I have told you, like there are two mechanisms in the excited state now, whether the excitation can be happen in the acceptor or in the donor. So based on that we can represent the particular one. So this extra energy term, look at this. This extra energy term contributed to our overall expression as a negative value, right? As a negative value. So what happens is, this is basically the term represented in our previous way, which is in the ground state, right? Apart from the ground state, the main difference between the ground state and the excited state is this extra term. This extra term is negative value. So the delta G term in the excited state is much more negative than in the ground state. So if I write here delta G, so this is for the ground state and this is for the excited state. As you can see, in the excited state, there's an extra term which is negative. So when we compare the delta G values in the ground state and the excited state delta G value is much more negative, which means this is much more feasible. If you remember, more negative means the delta G value, more negative means it's much more feasible. So the electron transfer in the excited state is much more feasible than the electron transfer in the ground state. So this is what you need to understand. Okay. So this is basically the electron transfer which we are talking about the grounds, which we are talking about in the photochemistry. I hope you get the idea about it, right? So it's not a huge complex thing, but what you need to understand is the key differences between the ground state electron transfer and the excited state electron transfer, right? This is the key difference. And when it comes to the delta G values, this is much more negative because of this additional term which representing this excited state, right? So in the ground state there are no excited state, no, so there is no additional term. This is the energy term for the donor and the acceptor. But when it comes to the excited state, there is an additional term to represent this excitation. So this additional term contribute to our particular expression using a negative as a negative value. So which further reduce our delta G value, and it will make us more feasible in the excited state electron transfer. So this is the summary of this electron transfer. If you have any problem, please feel free to comment below. I will try my best to answer those things.